So where might you find the maximum and minimum solutions here? Now we just talked about in this lesson that the optimized quantities or the optimization of a situation like this are going to happen at the corners, right? Or where the intersection points of the boundary lines or regions are. So a couple things that we'll want to be careful of here. And we look at this, there's restrictions. So x and y are element of all real numbers, so it's shaded in completely. The constraints are x is greater than -4. Notice it's not equal to, it's a dotted line. X minus y is less than or equal to 8. That's going to be this line, this oblique line, this slanted line right here. Okay. And also y is less than 3, so that's this line here. So these are your boundaries. The corners are, well, 11 and 3, that's going to be a point that's in the solution region, because these are both solid lines here. This is technically a corner, but notice that it is an open circle there. You see that open circle? So that point is actually not included in the solution set, but it is a corner, and as I mentioned in the lesson, the maximum or minimum values could be very close to this point if the point itself is not in the solution region. And then of course the other one is -412. This is another corner. It's an open circle, so that point itself is not included in the situation, but you could have one that's very close to that. So where might you find the solutions? So here's the objective function. Well, you might find, I believe that maybe all they're asking for is at 11, 3, or near -4, 3, and near -4, -12. Okay? So where might you find the maximum and minimum solutions? It's going to be at this point, or near this point, or near this point. And if they ask you to actually find the maximum minimum separately then, which I will do with you, let me just check. Yeah, so the question does ask you to do some calculations. So here's the objective function. This is going to be really easy. We want to test each of these 3 points over here, okay? We want to test them. And if we find a minimum value at 11.3 or near -4.3 or near -4, -12, then we would say, at or near those values. So let's check those real quick. So let's check the -4, 3, 1. So this is 2 times -4 plus 5 times 3, right? So that t is going to be -8 plus 15 or 7. 15 minus 8, right?
Yes.
Okay, so that's going to be near that number. That's near that number. The next one, we'll do it in a different color. Let's do the -4, -12. So 2 times -4 plus 5 times -12. That's going to be -8, and that's going to be minus 60. So that's going to be -68. Okay, so that's a pretty small number. That's really small. So near, this is going to be near -68, might be a minimum. And finally, let's do at 11 and 3. So t is 2 times 11 plus 5 times 3. And these are both positive numbers, so that's going to be pretty good. That's obviously going to be the largest one. So that's going to be 37, looks like. So this would be at that value of 37, right? So the question says, where might you find the maximum and minimum solutions? So looking at these numbers now, you would say the answer would be near the point -4, 12, but not including, because that's the lowest number that we've calculated. And so is a minimum. And at the point 11, 3 is the maximum. Okay, let's get that all on one screen for you. Okay, take a look at that. Any questions there? Now that's the first part of that question. There is a model B as well. So if I go to the textbook here, there's model B. So it's up to you guys to do that one on your own. And then question number 2 and question number 3 are also part of your assignment. Okay? Okay, so questions 1 and 3, you have about 13 minutes to work on that.